Hello, I thought I would do a quick demo of how to draw a little circuit and simulate it with Mosaic and Pinterest. I hope this goes well. So let's jump in. This is the library manager. And this is sort of the default library, which is synchronized with the cloud database. And you can add a new one here if you want that's synchronized with another database or not at all. But for now we'll work on this one. The first thing that I did here is add devices for the Skywater PDK. So it has a template for referencing it and a template that declares the device, which is just including the thing. And the same for NMOS. You can add more schematics here and the other devices and stuff. What I want to do is sort of draw a simple opamp design. I already have one here that sort of have as a reference to peek at, but I will try to draw it from scratch here. So live demo version. So yeah, sort of this has sort of a decoupling from cells and schematics, where a cell is sort of an interface and a schematic is sort of the implementation. Okay, what I already did for the cell, then what I will not repeat is this, where you configure the ports. So I made all these port names for the device, and we'll see that when we embed it in the test bench. But for now, let's just open it. And now we can start drawing devices. So let's start by drawing a MOSFET, but you can do by pressing M. Just a simple, let's say we want to use the Skywater one, and we want it to be a width of 1, a length of 2. This is going to be a current mirror, and we can flip that around with F. So let's add a current input port, which I did with P. I call it bias 10 microvolt at microamps. And then with W, you can start dragging wires. Connect the bulk up. G ground node. W wire. So this can be our current mirror to start. Select this, Ctrl copy, Ctrl paste, and then flip around. They did something weird there, but okay. Connect that up, connect that up. I want it to be there. A bit more narrow. No. Let's run this wire up here so we can pass by to the last device, because we need another current mirror. For the output stage. But this one, if I remember correctly, yeah, has 10 times the current, and this one has twice the current. This is the multiplier for the number of devices. So now we can hook that up, connect these to ground. You'll see the red circles there indicating that they're not connected, which is nice, I think. Now the actual current mirror. So we need more MOSFETs. I guess I can just copy these. Otherwise I have to, you know, keep repeating. Oh, what happened there? There, boom, flip. Hook that up. Oh, okay, something weird happened there with the copying also. these only have one multiplier, I seem to recall, but a width of 10 and smaller length. Give those a port, boom. So call this one in N and in P, and then the current mirror on top of that, which is PMOS, which is Shift M. Boom. Yeah, I can just drop them right on top of each other to make it more compact. And now Shift P will make you a nice power supply. And here we need, we need to set this to be PFETs with a multiplier of 1, a width of 1 and 0.5 length. Also sky water thing. Copy that to the current mirror there. Not a, yeah, okay. That seems to be about it, I think. Ah, no, this one needs to be 10 devices. And then we need an output port. There. Double check that we have everything more or less matching with what I did previously. Well, we'll see what happens. So now back to the library manager, we can add a test bench. I also did one already, but let's just make a new one. So we'll want to add the sub-circuit, and then we can say, okay, we want opamp, live demo implementation. And then we can start making sort of a test bench thingy. So hook up an output. And let's say we want a power supply somewhere. 1.8 volts. And with V I can add another one. And this one we want to do a sine wave, so like 100 millivolts, 1 kilohertz or something. Eventually it will be a nice interface for this, but now it's just typing it out. And to sort of center this, I will add sort of a little voltage divider. Oops. Make a ground node. Well, we can give it a supply if we want, but it's not strictly necessarily, I guess. Can also add a current source here with the 10 micros input. Little spice annoyance that you like. It flattens the thing, so if you want to name this wire, you have to have some wire segment. So like, we'll see later why. That's it pretty much, I think. Yeah, let's see what happens. We can also adjust it later. So start the simulator now. Interesting. Let's see if it yeah, no, it's fine. Okay, so we can just do a transient simulation, see what happens. This is quite slow because it's what's going on here? Interesting. Somehow, like, it's supposed to show the simulator output here, but it's just not doing that. So let's see, we can also go to the notebook and it's the same API as the simulator, but here you get more insights in what's going on. And maybe suffer less from demo effect. So this part just gets the netlist. And this is the part that should run the simulator, which it's doing. Okay, seems like I have an error in my spice generated undefined number script. What does the spice netlist look like? Oh, interesting. Oh, this is still the old one. What did I name mine? My test. Let's try that one. So far so good. Oh, I forgot to add the input ports at the top level. So I was trying to plot this, but it's not in the schematic. So it's in here, but not at the top level. So when running this one, it's on the top level, so it needs to be there, of course. Okay, there you go. Simulation with times and stuff, and you can zoom in even more. Let's give it one more try in the UI, see if that works. It should be the same thing basically. Ah, there you go. Just had to be a bit patient, I guess. And again, you can see the plot and pan around. And of course, you can also do other simulation. Like, I'm not sure. I didn't set up AC simulation, but let's try this one actually. Let's see if we do this. It doesn't work so well with Skywater because the loading times is so big, but it should be the case that if I tell it to watch for changes. Oh, here's another thing I forgot. Hello? Anyway, I think that's enough demo effect for the day.